So, I mean, the very, very, very basic intro is that Elm is a language that compiles to JavaScript. So instead of writing JavaScript, you write Elm, and then you compile it and you embed it into, you can either embed it into an existing JavaScript app, but like the simplest way to do it is just to have the whole app be your Elm app. And you have like an index page like you would normally HTML that just says import this script, and it's the compiled Elm script, and then it runs it all in the browser. And the reason why Elm is unique to other compiled to JavaScript languages is because it's a purely functional language. So there's no objects at all. Everything is a function, and therefore every function has a return. So there's no side effects. There is a way that it deals with side effects, but it's basically purely functional, and it's statically typed as well, which is different to a lot of other typed languages, which can be dynamically typed, or even like a language like, say, TypeScript, where you can use it typed or not typed, which all of that is like very, very technical, I am aware, but basically the massive benefit that you get from Elm is that you can't break your code, essentially, and it will tell you at compile time whether something is broken, so you don't get any of those like null pointer exceptions, or undefined is not a thing, or can't access blank of undefined. None of that will happen in your production code. So I'll just go ahead, and this is like a longer length talk that I gave a couple of years ago, but I'll go ahead and like flip through it to get through to the examples so you can kind of see what I'm talking about. And then we'll see where we go from there. Hang on a second. And if at any time I'm like talking too high or too low for you, please like ask me questions in the chat if something that I've said is confusing to you. So this is me. And I don't have Twitter, but you can see me on GitHub, and you can reach me on email. And I also run an organization called Code Reading. So one of the things that like is amazing about JavaScript is that it's universally supported on all browsers, and it's really easy to get started with JavaScript as well, which is why it has such an amazing take-up. But the problem that happened with JavaScript is that the kind of, I wouldn't say the market got flooded, but if we go through to this, you can see that all of those tools at the bottom there are JavaScript tools that have just come about like within the past 5 years or something. And so the whole ecosystem is like mind-blowingly complicated. So now for newcomers coming into JavaScript, it's not actually as accessible as it used to be. And that is where I think Elm has a really good place in this ecosystem, because it is phenomenally easy to get started using Elm compared to getting started to using any of the big JavaScript frameworks like Vue or React. So I'm just going to try and run through. So this talk I designed was to demonstrate like how people at the bottom are the ones that we're wanting to talk to when we're writing our code. And even though the code that we write ultimately is like compiled and run on the computer, the one at the top, the people who are going to have to maintain the code are us. And we don't like those complicated systems. We like things to be very straightforward. A is B, B is C, and therefore A is C. And that's very easy for us to reason. And some of the, well, all programming ultimately becomes complicated, doesn't it? But Elm sort of makes it easier for our brains. So this talk was designed as like looking at two different teams, one that chose to build a new project in Elm and one that chose to build a new project in JavaScript, and that's React specifically in this comparison. Some of the images in this presentation are upside down because I just really quickly compiled it from an old one for this impromptu talk. So just you can laugh about that or ignore it. So at the beginning of a new project, you are going to choose what, if you're building a web a web project, you're going to have to choose what compile to JavaScript thing you're going to be using. So this is the one team that chose React and one team that chose Elm. And the team that chose Elm, they're feeling very cautious because the patterns are new to them. They're going to need to figure out even like the most basic thing of how to render HTML on the page. And the other team is, I've got them feeling a little bit bored because they're like, oh, here we go again with this same old thing. And if you're anything like me or some people that I know, sometimes we get a little bit bored of using the same tools and doing the same things over and over, even though it makes things more predictable. And so sometimes it's kind of fun to like try out a new thing. So that's perhaps a little bit mean that I say they're bored, because it's never really boring being a programmer. But so this is how you write HTML in Elm. And it's basically, this probably like a little bit too far into it, the syntax, but because everything is a function and everything has an implicit return, you don't have any of those like keywords in Elm that you do in other languages. So when you define a function, you just have to write the name of the function. In this case, the first function here is div, and every function will just take a list of arguments. I think like it's possible that these slides are out of order because this is quite advanced, but this is basically just showing you how to render HTML. And you can see that there's a div with an h2 and an unordered list, and then some list items in there. And hopefully it's pretty obvious what this is going to look like when it renders out. And then below it, you can see the HTML and the output of that HTML. So it's not too different to what you're used to. This is about like making a button and making a link. So these are all like HTML nodes, HTML elements. And so this is a button, and you can see that the first, the square braces in Elm are denoting a list. So this is like a button with a list of attributes, and then a list of what is inside the button. And then same thing with the A, you've got an anchor with a list of its attributes, and then a list of what's inside the HTML tags. And in React, actually under the hood of the JSX, it's doing exactly the same thing. So React and Elm were both kind of like invented around the same time, and they did share patterns back and forth together. So React, when you do the JSX for like a button, is behind the scenes or under the hood is running a function called create element, which takes the type of thing it is, the attributes in an object, and then the contents of the tags. So it's functionally actually exactly the same. So some people get worried about when they're first starting to write Elm, that they get confused about this new type of like indentation and things, which is really important in the Elm community, that everyone uses the same formatting conventions and style conventions. It also means that you don't have to configure anything. I don't know if you've ever tried to start a new project in the JavaScript world, but you have to have like all your prettify and your ESLint and all of your tooling and your Babel configs and everything, all of that, like you have to agree in your team. And in Elm, it's much more like agreed at a community level, which means that you don't have to have those like arguments and choices within your local team. So this is one such tool that every Elm project will use, called Elm format. So if you were to write your Elm in the way that like you're more visually familiar with HTML, then you run Elm format, which normally you would have that just runs on save in your editor, and it brings it into the Elm way. And one of the curious things about it that people mention is that's very obvious at the start, is the leading commas. And the leading commas make it like phenomenally easy to not to compare code diffs. So a lot of times when you do changes to lists and things in JavaScript, you would not have, you would either have trailing commas, which are like semantically useless, like they're not really meant to be there, but they're literally there so that people don't forget to add them when they add new elements, and then like have a hidden broken bit of code. And if you don't have trailing commas, then when you do a diff, then it looks like you've changed like 3 lines when you've only changed 1 line. So that's one of the things that, like, there's a lot of things about Elm that mean that you get these benefits that when you first come across it, you're like, oh, this is really frustrating. It's so different to what I am used to. But then within a couple of months of using it, you actually find out that that you really love them and you get used to them, and you can see those patterns being implemented in other like languages and frameworks as well. You can recognize them, and they're usually implemented like as bolt-ons. So like TypeScript, for example, is types for JavaScript, and with Elm you get it for free. So yeah, with CSS, there's loads of different ways you can do it, but the simple answer is that you can do CSS just like you do CSS in your other packages, in your other frameworks, by either including a style sheet, or you can do, there are patterns that are like style components that you can use. There's another whole framework in Elm that allows you to, or not framework, just a library in Elm that allows you to not write CSS at all, but use a totally different paradigm, which is called Elm UI, which is about like UI components. So there are questions, but the easiest way to start is just to start like what you're used to, and you can, yeah. The Elm architecture is another thing that is a pattern that was is like what Redux uses, basically, where it's the way that Elm manages side effects, which is that a user will, it has like a single loop flow where you have a user will do an action, so like typing into the keyboard, and that gets put into the browser essentially, and that will send a message which triggers an update, which does a state change to your model, and then that new state is rendered in the view in using a virtual DOM algorithm. And that is the only way that you can change the state of what is on the screen. So there's nothing that happens outside of that loop. So this is a look at basically what the state machine, like it's this, like what Redux calls a state machine. So on every program, you define a model, which is like the things in your state that can change. And then you define an initial model, which is like what your state is when you first start the app. And this one is just saying lights on, which is a Boolean. And when you initialize it, it's true. And that's similar to in Redux, these messages and actions. But probably, I don't know, at the beginning of this, we were talking about having like an intro. Probably people aren't using Redux anyway, who are in this chat. It's very hard to tell, the audience. But anyway, that's the basic idea. And I don't know if I am looking through my slides to see if I've got any. I think this next one is like, you can't really see it very well, but so we might be better to go ahead and just like run through an Elm program ourselves now. I'll show you how to like initialize it. I'm trying to check just how much time we've got left. We got half an hour left. I think we've got about half an hour left. So what I'm going to do is probably slightly brave, but I'm going to stop sharing this screen. I'm going to go ahead and share my terminal. We'll just make a brand new app together. very quickly. So I've just got a couple of terminals open here. And the first thing that you would do when you are making a new Elm project is to just make a new folder to put it in. And you go inside there and you just write Elm in it. And to get Elm, you just you can do npm install Elm. And so this is the text that you get, which is telling you that it will create the little initial Elm project for you. And basically all that does is create an Elm JSON, which is similar to a package JSON, and a source directory. And there's nothing in the source directory. So literally all it does is create you an Elm JSON file. So you can see already that like the boilerplate is nice and small, right? And this is like your package JSON. And you can see like it just has dependencies, the name of the application and stuff. So then you say, well, that's great, but I can't run anything. So the convention in Elm is to have your Elm program in a file called main. And what I'm going to use is just a quick sample program that is on the, I don't know if I can share two screens. Do you think I would be able to? I don't think I can. I'm just going to paste a link into to the Elm guide in case people want that. So this is basically where I'm getting in the very, very beginning of the Elm guide. The Elm docs are really, really good to get started with. There's a program which is a button that increments up and down, which demonstrates like state control. So I'm going to copy that. And I know it's going to give me an error when I do this because I haven't exposed. So this is the program. I'm using import browser, import HTML events, and those are all in the core of Elm. This is a sandbox app, but you can have an application which is like a full application that you embed into an index file, or you can have an application which is called an element, which is like a node that you embed. So if you imagine you had like a big React app, and then on one of your pages you had a tiny box where you had a little quiz or something in that box, you would be able to put the Elm just in that div and it would run. So when you're developing it, you have it as like a standalone thing like this. And so this is basically your main program, which is that what type of program you're going to be. And they're all browser-based programs because Elm is a language for writing for the browser. And then you define, these are your messages. So these are like potential updates that you can make. And in this case, to your state. In this case, you can either increment or you can decrement. And then these update function is the definition of how you do those updates. So if the message is increment, then you add one to the model. And if the message is decrement, then you remove one from the model. And in this case, he hasn't even like explicitly defined the model in this example, but the model is an integer. And so that's all you can do. What we'll do is we'll like add to this and make it like slightly more exciting on the fly if we can. So the first thing that happens if you were to do exactly what I've done now, if you do Elm Reactor, which is like the live Elm, let's see. Address and use. So I just need to choose a different port because my slides are running on that port. Let's go for 3000. And now, if I can share this whole screen, so let me open a browser on here as well, and then we can look at it. So hopefully you can see a little bit bigger. So this is how easy it is to get started. And I know it's going to give me an error in a minute because, so this is basically Elm Reactor like makes a live Elm compiler in the browser. So you can go browse through your source code, and I should have put my main file in Elm. I'm going to go ahead and stop this for a second do it over here. What did I call it? My Elm. And then I'm going to move, because that was a mistake I made. It doesn't really matter. Obviously, it will still work. But if I do that, and oh, I made the same mistake on the port. I could just turn my slides off. I kind of lost my thread in my slides anyway. Okay, so now if I go into the source and I go on main, it tells me that the module name needs to be declared at the top of the file. And so I'm going to go ahead and do that. It's because that program is designed as like an excerpt example, isn't it? So it tells me exactly what I need to do. So I'm calling this, I'm calling this a module. And it's called main, and it's, and that dot syntax just means exposing everything. Oh, I don't know what happened there. Hang on. Right. Let's see. Ta-da! There's a tiny little counter over here. So the first thing that I can do, which is like a bit of a hack, I can add a style of some padding. Oops. And let's just do like 100 pixels. And if I do that, I don't know why it's... Oh, I think my editor is like trying to tell me about my errors, which is helpful, but I think because I'm not, let me see if I go in here. Yeah, there's something gone. But basically the error I can see is that I can't find a style declaration, and I'm just wondering if it would be more helpful for us to see reloading compiler. So basically the error that I'm getting that's down hiding in my editor is this. I can't find a style variable, and that's because I haven't exposed style as HTML attributes. So, oh, I know what's going wrong. I had the resize mode on. So what we want is HTML attributes, right? Which are all, this again is a core library, style. And it's going to keep telling me that. So let's see. We should have set this up slightly differently rather than trying to do it on the fly. Keep doing that. So there, I've added some padding. And that obviously will get like very messy in a very short while. So there's a library called Elm CSS where you can add CSS, which is like style components, or you can just have like a Sass compiled sheet next to it. What I'm trying to find out is if I can have it running, if I can have the window running in the same, so that we can see my compile errors at the same time. I'm not sure. And I was also going to maybe try and ask people what types of things that they want at this point. I'm going to just take a break and then see if people want to ask me to go into like a little bit more detail about about what anything is and wait to hear if anybody has any questions. And you can feel free to also come on the video if you wanna voice your question with your voice.
I have a question actually. So you say this compiles to JavaScript. Is it possible to use existing JavaScript libraries within Elm, or would they have to be sort of ported to Elm language in order to use them?
So when you say to use JavaScript libraries, yes, it is possible. There is a thing called ports, which is the way that that Elm will talk to you, like surrounding JavaScript. So, for example, like a simple example would be if you were using like a Google Analytics script and you have to pass it your like UA number, then what you do is you make a module that is a port, and it passes the values in and out with flags. So you would make your initial program take a flag from the outside if you needed stuff in your Elm app that was coming from JavaScript, and then and those are like flags that get set on initialization of the app. And then if you need to pass information back out into a different JavaScript program, then that is a port where you have like a fixed type of like a fixed structure of information that goes out. So yeah, it's totally possible to do that. So normally, like if I look at like an existing, I'm trying to make sure that I choose like an open source one, that I'm not sharing something that shouldn't be shared. But if we look at like a real world JavaScript, Elm project, then the root of the project is like this. So I normally just carry on using Webpack. So I have those, you've got your package and your Elm stuff there. I'm just trying to think if this one actually has any ports in it. It has the word port a lot. Let's see. No, I don't think this one does. But yeah, it is perfectly possible, and there's loads of like good talks about that as well.
Okay, thank you. Yeah, Google Analytics was sort of exactly what I was thinking of. So it's very interesting.
Oh, was it? Yeah.
Yeah.
Yeah. This I thought this one did. Let's just go in here and see what we've got. I thought it did use Google Analytics. Yeah, it does. So the analytics module for this just looks like, so it is a port, and its type is a Google Analytics event with a category, an action, and a label, which are all strings. And this is a function called update analytics, and it takes a Boolean and a command message and returns a command message, which is the way that Elm communicates with ports. And then these are the two port definitions. So then whenever it gets called on probably the main, I think that's where the updates are in here. I haven't looked at this code base for a long time, so I can't remember. So this is like the main function for that whole real world app. And the update functions that are possible here is page link clicked. And when a page link gets clicked, it will run that update analytics event. So it's a little bit confusing unless I went back through this line to line, because it's like a mature code base. But yeah, basically every time a page link gets clicked, you fire off that event.
Yes.
Does anyone else have any questions, or like potentially, I guess it could be helpful for me to take like a piece of this code and just walk you through what it is. Or we could go back to our other example and try and add something to it.
I had one other question actually, just around how big the Elm community is, and whether many people are actually using it?
I don't have like exact numbers. There's not enough people using it that it registers as one of the main frameworks, obviously. But the community is big and active. They have a Slack, which I would encourage you to join, even if you are just thinking about looking at Elm. And they have a Discord as well. They have a couple of Discords which are like run by different groups. One called Incremental Elm, and one is called Elmcraft, I think. And they have a meetup, like an international, since the pandemic happened, they've been doing the meetup as international rather than like the different cities. So that's worked out really nicely. That is usually monthly, and it's on a platform called Meet Down, which is like an Elm clone of Meet Up. And there's usually about 40 or 50 people at that. And the same with, I was in the London group, and there was normally like 20 to 50 people turning up, depending on who the speakers were every month. So, and they have like 5 conferences, but they're all on hold right now because of the pandemic. So, yeah, so there's a lot of people in Scandinavia. That's one of the big groups. There's a big one in Japan as well. And then there's a lot in America. There's quite a lot in Canada and the UK, obviously. Yeah. So yeah, it is definitely actively being used.
Oh yeah, sounds like the community bigger than I realised, I think.
Yeah, and there's a lot of code in production. Like, yeah, there's a lot of people using it for like big apps and across a lot of sectors. Yeah. Anyone else have any questions? Feel free to either type a question in the chat, or because it's difficult like presenting to you all when I don't know what your perspective is, because if you just think it would be helpful to like go through some more getting started examples, or kind of like explaining either the syntax or explaining how a thing like will fit together. Go back to that example. I just wanted to demonstrate, like, if I wanted to add something below here, then basically with an HTML node, every single HTML node is the name, like the name of the function, and then they all take an argument of 2 lists. So this is unhelpful, but basically there's no you don't have to write explicit signatures on your Elm functions, but you should, but they can all be implied, so that's why you don't need to. But so this takes an int and returns an HTML message. Oh, I don't know why I don't know what that error is. So that when you do a lowercase, that is like a generic, and this is explicitly returning this type of message. So that's why that error was happening. So this basically is saying that it returns an HTML node, which always has a message attached to it. And that means that I can add anything into this list that is an HTML node, and it can kind of go on indefinitely. So I could add another div, which has a list of attributes and a list of contents. And inside that div, if I wanted to add a list, again, that UL takes a list of attributes and a list of content. And so inside that list, I would have a list item that is a text, And text is like the leaf node of HTML, where it just has like its content. So now when I try and save this, I don't have a UL or an LI defined. So I just need to go ahead and import them from HTML, and then it should be happy again. And let's see what it's done. Right. The first argument needs to be a list. So now that should be happy. And because this isn't in like my main programming environment, it's not set up to be formatting automatically. So if I come out of here and I just run Elm format, it's going to probably tell me, let me see, NPM. And then I do Elm format. Oh, you are. Sorry. So now it's going to overwrite that main. So now if we look back in the main file, it's formatted it for me. So like when I was typing this out, I didn't have any spaces between any of those things, and it's nicely done that. And it also alphabetizes all of your imports for you. It alphabetizes them inside the bits that you're exposing, and it also alphabetizes your package list. So that again is like super helpful with like Git diffs between developers and knowing what exactly has been added or not. So I'm trying to think of like what a good thing to show how powerful it is in terms of like not being able to break this. If I were to change, it would break, but it might be more better to show like a more mature example. Again, does anyone have like any questions or confusions where they want me to focus? Because I could just go through some of like the official docs and see if people have questions on that. I'm trying to see. There's another guide actually, which is called like Beginning Elm, I think. I do in my slides have some, but I couldn't find them as easily as I thought. You see, let me share that. Let me share my slides back again. I also can't remember how to get like the overview of all the slides. Yeah. So this series shows how what the syntax is like, basically. So this is just a string concatenation, hello plus Norwich. This is if you divide with a single slash, you get a float result. If you divide with 2, then you automatically get the rounded int. If you so this is the square bracket, a list syntax, and the list has all the like normal functions you would expect, like getting its length and reversing, and they're all like very predictable. You know exactly what you're going to get back because all of the functions that are like defined in the libraries that you use are going to tell you exactly what their return types are. So if we went to list the docs, All of the packages are held in the Elm package repository, and they all have to conform to like the same formats, so otherwise they won't get published. And so every single package has docs that look identically like this, and it will tell you the function signatures for all of the exposed functions from that module's API, and have an example. And if ever they publish a breaking change to the package, then the semantic versioning is enforced. So they can't publish a breaking change without the version number reflecting like a major change. So these are all the Elm core packages. So they just come like as soon as you do Elm init, then you have access to all of these basic like types. And so this is a list, and it can tell you everything every function that is exposed by list. And so like length takes a list of generic A and returns an integer. So maximum takes a list of comparable things and returns either a comparable thing or nothing if there is no maximum. So coming back to this, I don't know if I want to go down or cross down, probably. So then they have tuples and records. Tuples is because, well, it's not because, but like a list is like an infinite thing that can either be empty or have a lot of one type of thing in it. So you can't have a list that has like some strings and some integers in it. It has to just be all strings. A tuple is kind of like it's a way to make like a record type without having keys on your properties. So it's like, if you basically like, this is a common pattern. The failure success is like on an HTTP request, you either get false, as in like an error and some text, and you get returned to the home page. And if you have success, then you get success and hooray text and next page. And so like if you have like a pattern that you're repeating where you need like 3 properties for one thing, or 2 properties or 4 properties, or whatever, however many you need, you can use that, but it's less explicit than using a record. So this is a record, and it looks a bit like an object, but it isn't an object. It's just a thing with a specific shape. So it has to have attendees, which has to be an int, and name, which is a string. So when you define it like attendees. A number is either an int or a float, and a string. And then this is an example of a simple function. So always a function, like I said before, you don't have to put the type signature on because it can always be implied. But it's very helpful when you're like reading the code to have them. So this is which takes 2 ints and returns a string. And so on the actual function line, this is like your function name and your parameter here. And so then I'm saying string from int x. And does anyone want to try and guess what this does? I can't now see the chat. So it's making a string that says 2 + 3 = 5. And I'm just demonstrating that you can't have like one of them be an integer and the other 2 be a string. It has to just return a whole string. Ooh. So then these are like some logic flows. If always has to have an else, because you can't ever have a function that doesn't return anything. So you always have to do if something, then do this, otherwise do this other thing. And one common pattern in HTML is like sometimes you want a div to appear if you're a logged in user, for example. So you can be like if has user, make this div. Otherwise, the convention is to just do text empty, because you can't otherwise do nothing. You always have to do something. So this is saying like if it's the morning, say hello. If it's the evening, say goodbye. If it's midnight, don't do anything. And anything with a capital letter is a type. Anything with a lowercase is like either a generic or a function. There's 2 different ways to write. So if you're familiar with like Lisp style languages, then you'll be used to closures, where it's like a nested function where it runs kind of from the inside out. So this function takes this. You can see it's enclosed in parentheses, which is another function called then this function, which takes this as its parameter, which is first this function, which has data as its parameter. And some people find that easier to read if you write it the other way around. So in this, so this is called piping in Elm, where you start with the data and then you run this function on it. So it's the same thing as the one at the top. It's just like visually, some people find it easier to do like first this, then this, and finally run this one. That shouldn't be a capital F there. This is another example that I gave for like, I don't advocate using create Elm app either, but it's just like an example of like, if you run create React app, and this was a couple of years ago that I did this, there was like 2 million lines of code. If you run create Elm app, at the same time, there was 20,000 lines of code, and they are exactly as powerful as each other. Like you can do exactly the same thing in them. I'm just trying to see if there's like useful things. So this is an example of what is called a custom type. So one custom type that you will always use in your programs is a message, because that's like where you hold your update function definitions. But you can define custom types for anything. So you just write like type space and then whatever.
Sorry, I can only see the presentation. Nothing else. Sorry, I just tried typing. Yeah.
Okay. So what can you see or not see?
Just like the presentation functions. I can't see your terminal. Oh
yeah, because I can only share one screen at a time.
Oh, okay.
So it wouldn't let me show my terminal at the same time. Sorry. So I'm trying to think if I have a good example that I can show. But essentially you can actually, if we look in if I look in there, there's two different things that people will talk about. Type alias is like a record. So you're defining a type alias, which doesn't have a constructor, but it's basically a user is a thing that has a name, which is a string, and an age, which is an int. And so then anywhere in your program where you say this function takes a user and returns a Boolean, you have to have a record that has a name, which is a string, and an age, which is an int. Otherwise, when your program compiles, it will say that thing that you're passing to is old enough to vote is not a user. And the reason it's not a user is because it's missing its age field. And so that's really, really powerful then if you change the shape of your user. If you then wanted to add a gender to your user, all you have to do is in your type alias, you do gender string, or even you could do gender is a new type that you define called gender type. And then everywhere in your code where you had a function that took a user as its argument, it would flag up to you that you're missing the gender type. And that is super, super powerful. So people call that like a style of programming called compiler-led programming, where you make a change in the endpoint where you want to see it. So I'll often make a change like right in my data type, like right in my user type, and then follow whatever the compiler tells me to update it. Everywhere that I render that user type, I have to add the gender. And or I will do it on the other end, which is the actual output, like the view. So if I know that I want a view that has a user in it, then I'll put that user in my view, and then I'll follow the compiler to tell me where I need to add, like update my data shapes to make it that user feed into that view. And the other type of type, which I was talking about, is these custom types, which is what a message is. And you have to do two declarations, or that's how I think about it anyway. So that is type rather than type alias. User status is either a regular or a visitor in this case. And that means that anywhere you can use you can use them both as like variants, if that makes sense. I don't know how the best way to explain it. And they can then take like different types. So regular user takes a string and an int to make itself, and a visitor only needs a string, but they're both users. So then in your code, you can use the type user, and you have to make a path in your code for what if the user that turns up here is a regular user? What do you want me to do? If the user that turns up here is a visitor, what do you want me to do? And you can't compile your code until you've made a path for all types of user in every eventuality that they could turn up in your code. I don't know if that makes sense. So then he's gone one further and he's put anonymous as another one that doesn't have any arguments. And then, so then he's used the user type here. And that could be any one of these three things, but it's like, I don't know how best to show the power. Hopefully you can see how powerful that is to do that. So in my example, I'm just going to try and find like a pattern matching case statement, which I think I showed you one already. And my slides are a bit messy. I don't know. So here's like a color type that I defined, and then your model has a color, and then you know that anywhere the color turns up, it either has to be red, green, or blue. And then it's annoying that I didn't make one, but basically you make a case statement. So you do case color of red, do this, case color of green, do this, case color of blue, do that. And generally, you wouldn't necessarily do those inline. You might do them like in a separate function somewhere else so that your code will read like very like succinctly in your actual like view code. You can see like if you just wanted to like write red into your CSS at that point, then you would just like do something like get color style or something. And then the get color style function would be the one that takes a color and returns red, green, or blue string or the hex code that you want for those colors. I think we're out of time. But if anyone has a question, that was really difficult. Do you have another question?
No, I just wanted to say that was very enjoyable.
Cool. Well, yeah, it wasn't very organized. But yeah, thank you.